So now let's solve this particular question, and it is a matching of PQRS with 1, 2, 3, 4 option, and one by one let's go. So first is the easier one is m equal to malloc 10 and m equal to null. So it's a pure case of lost memory. We have allocated, if you see Q, so it's a case of lost. We have allocated memory block of size 10 and then we have make it null. So the allocated memory block will be lost. So it is matching with 4, because if you see the option, a lost memory which cannot be freed, means memory is lost and we are not able to free. Now if you see the R character pointer, so R is pointer array of P10. So what is this? It's an array of pointers, right? And it means we have a pointer. So this is 0, this is 1, and this is 9. So each will point to some location. As it is a pointer to character, so they can point to some string. Each character can point to some string. So sequence of memory location to a store address. Here we are having what? It's a pointer. So pointer is nothing but a storing address. So the R is say equal to R is matched with 1. Now the register int variable. So S. What is S? S is register int. So register is nothing but register is there in CPU. So it is a request to allocate a CPU register to store data. So S is nothing but 3. So what we left? We left with P and a static character variable. So a static variable is also stored in memory. It is only stored in memory. So a variable located in data section of memory. So it will be what? A variable 2. So if you see P2, Q4, S3, R1, so option is A. So correct option is A, which is end of the question. So now this question is about BFS. There is a graph given, and it is asked that BFS is implemented using Q data structure. Which one of the following is a possible order of visiting the nodes in a graph using BFS? So let's start. So the graph is M, N, O, Q, this, R, this. Right. So the question is, see, in BFS what happens? A source vertex in all cases is in first case it is M. So the first vertex should be the source vertex, and in BFS we discover the vertices uniformly across the breadth of the graph. Means we can in BFS first discovers all the vertices at distance 1, at 1, then all the vertices at distance 2, and so on. Means because this is because of Q, because if you in Q, suppose if you push M, so if you push M in Q, so if you insert M in Q, so after M the distance of M to N is 1, 1, 1. So after M, N, Q, R is visited, and the distance of O and P are 2. So when all the vertex of distance 1 visited, then only we will visit the vertex of distance 2. So before visiting any vertex of distance K, we cannot visit a vertex of distance K plus 1 from source. So if you see, the first option is M, N, O, P, Q, R. So M is a source, so from M, N is at distance 1, O is at distance 2. See, this is wrong, because from M, N, Q, R, N, Q, R can be visited, then only we can visit O, because from M the distance of N is 1, distance of Q is 1, distance of R is 1. So after M you can visit in any order. So if you visit R, Q, N, then only OP will be there, because if you visit R then it's okay. If you visit Q, so when Q will go out it will bring O and P, and then N it will bring. So first option is wrong. Similarly N, Q. The second option is N, Q, M, P, O, R. So here N is a source vertex. So from N Who are the vertices at one distance? So from N we are, M is at 1, O is at 1, Q is at 1. So you cannot visit R and P before M, Q, O. So if you see, this is incorrect. So after N we are visiting P before O. This is wrong. So P cannot visit it before O, because P, distance of P is 2 and distance of O is 1. So this sequence, see, if we are negating the option, we are negating. So if this from N the distance of O is 1 and distance of P is 2, so P cannot visit this vertex of distance 2 cannot visit the vertex of distance 1. So now, so B is wrong. Then option C, third option, right. The third option is Q, this is 3, Q, M, N, R, O, P. So from Q we can visit O, N, M. See, and R is at distance 2. So this is also not true, because before O we cannot visit R, because the distance of O from Q is 1 and distance of R from Q is 2. So it is not true. So 3 is false. 4, then P, O, Q, N, M, R. So as all 3 are false, so it will be true. So from P we have O, Q. After P and O, Q. After O, so it will be N. So when O will come out, O will bring N into Q. And then when Q will go out, it will bring M and M will bring R. So this is the right answer. So the right answer of this question is D, and this is the end of solution. Now in this particular question, we are given a circular queue that has been implemented using a linked list where each node consists of a value and a single pointer pointing to the next node. We maintain exactly 2 pointers, front and rear, pointing to the front of the node, and rear is pointing to the rear of the queue. Which of the following statement are true, correct for a circular queue, so that insertion and deletion can be performed in order of one time? Next pointer of front node point to the rear node, and next pointer of rear node points to the front node. So it's a circular node. First is we want the insertion and deletion. See, a circular queue has to be implemented using a single linked list. So we have only one kind of pointer, single linked list, like this. Right. And here we have a front, and here we have rear. Right. And we maintain actually 2 external pointers, front and rear, pointing to the front and rear of the queue. Which of the following statements are correct for such a circular queue, that insertion and deletion? So when we insert, if you insert, so insertion will be done at rear, and normally we have a pointer to this because the circular queue. So if it is a circular queue, the rear pointer, next pointer to rear node should point to the leaf node. This pointer, if you point this, no problem, because this is not going to help. After first you don't go to rear, because you have already a rear pointer. So insertion, how to do insertion? How to do insertion? For doing insertion, what you will do? You have rear pointer, so you will make a pointer here, and you will link this, and from this you will make. So insertion can be done. And deletion, how we can do deletion? So the moment when we have to delete deletion, so if we don't have the rear pointer pointing to the first pointer, we cannot do, because it's to maintain circularness, it's a rear pointer should have the address of the front pointer. So answer should be next pointer of rear node should be to the front node. Then only because of insertion, if we have to add this, so here we have the pointer of this, so next of this will have the value of this. This will be the next. So here the next of this, suppose here we have 100, so we will do 100 here, and then we'll link to this, and 100 will be there. So the answer is next pointer of rear node points to the front node, and that is B, which is 2 only. So this is the end of question. So now in this question, again we have to match left side with the right side, and left side we are given algorithm, and right side we are given the time complexity. So see, Tower of Hanoi with n disks. So Tower of Hanoi we know 2 to the power n, because if you read Tower of Hanoi, the recurrence relation for Tower of Hanoi is 2 to the power t plus 1. Right. So this is Tower of Hanoi. And if you solve, this will give you order of 2 to the power n. So Tower of Hanoi will be 2 to the power n. So P is 3. P is 3. Now binary search given n sorted element. So if we have to do binary search on n sorted element, it will take order of log n time. So this is easy question. Binary search. So worst case time complexity of binary search. Binary search will be only applicable if we have elements in sorted order, and the worst case is order of theta log n. So the binary search, so Q will be 4. The Q will be 4. Now heap sort given on n number at the worst case. So heap sort, the worst case of heap sort is order of n log n. The worst case of heap sort is order of n log n. So n log n is nothing but here. So R will be 2. So R will be 2. Next, addition of 2 n cross n matrix. So if we have to do addition of 2 n cross n matrix, so in n cross n matrix we have a row and we have a column, each of 2 loop for row and column, and each will go to n times, so n into n. So the addition of 2 matrix requires order of n square. So S will be 1. S will be 1. So the right answer here is C. P3 Q4 R2 S1. So the correct answer is option C. This is the end of the question. Let's consider this question. Here we have a function print xy. There we need there is a 2 parameter passed with one is x and another is y, and there is a pointer. That pointer is having the address of x, and again we are assigning the value of y with the content of pointer, and we are changing the value in the pointer, and it is asking what will be output if we invoke print x with parameter as 1 1. Right. So let's discuss. So print x y print xy. So here we have int x and here we have int y. We have x and y, so that int ptr x equal to 0, ptr equal to x, y equal to d difference of ptr, d difference of ptr is equal to 1, and then we are asked to find printf %d %d xy. This is the requirement. So if you pass 1 1, so it says if you what will be the output if we invoke 1 1. So x equal to 1 and y equal to 1. Initially it is passed. And ptr ptr equal to x. Suppose if I say the variable x is at address 100 and the variable y is at address 200. So x equal to 0. So what we do initially ptr x equal to we do 0. So it is 0 now. It is 0 now. Then ptr equal to, so ptr has 100. The moment when we do, suppose this is also a pointer, is a variable, so it is at address 300. So ptr equal to d difference of x and y equal to d difference of y. So y equal to d difference of ptr. So the moment when we do y equal to d difference, so what is d difference? What is the value at 100? The value is 0. So y value is 0. So here we are making 0. Next, d difference of ptr equal to 1. D difference of ptr equal to 1 means here we are overwriting as 1. Right. And at the end what we are printing? %d x y. So the value of x is 1, the value of y is 0. So the correct answer is 1 0, which is C. So out of all, the C is the right answer. So C is the correct answer. So this is the end of the question. Now let's consider this question, and here we are given a C program and there is a pointer, character pointer, which stores GATE CSE IT 2017, and we have another pointer P which is initialized to C, and then it is asking to print something. So let's start. The question is like this: int main. Here we have character C, GATE CSE IT 2070, CSIT 2070, right? And another pointer is, see, if you remember that character can be represented using two ways. One is array of a string. This is a string. So a string can be represented using two ways. One is using pointer to character, and another is array of character, right? And remember, see, if we there is one more thing here. Let me write the question first. So printf %d, then it is int strlen, string length, so C plus 2p minus 6p minus 1. See, there is an interesting thing here, that 2p, suppose if the array is, suppose int a 5 equal to 10, 20, 30, suppose 40, 50. So if you write a2, what is a2? 0, 1, 2, it is 30. And even if you write 2a, this is also, if this is an array, so automatically it will give you 30. So both are the same thing. So similarly, 2p is same as p2, and this is same as p. So sixth member, those character which is at index 2 and the character which is at index 6, that will give you, it will give you, right? So this is the basic we need, and let's start. Right? So if we, so character pointer, so there is a string called GATE CSE, GATE CSIT 2017. So they are character, and in C, a string, every string gets ended with null character, that we understood. So 0, like this, it is like this. So it's a 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right. Now P is a point, C is a pointer. Now with this statement we have made P also a pointer to this. So C, so C means a string length C, C plus means this is a base address, this is a base address. Now P2, so this is C plus, what is P2? P2 is T. This is a, see, this is a pointer, this is data, minus 6p I minus 1. Right. Now see, in you can have the you can do the minus of two string, two character, and this conversion will take place according to ASCII value. So T has ASCII value, so there will be here. So if you have I, so if suppose ASCII value of I is X, so the T will be, suppose if ASCII value of I is X, no need to remember ASCII value of I is X, so the ASCII value of T will be X plus 11. Because if you see after I, the at 11th position it is T in the alpha in order, I, J, K, L, M, N, O, P, Q, R, S, T. So 11th. So if you do this minus this, this is going to give you, so difference of two character will give you the difference of ASCII value in between these two, equivalent ASCII value of these two, and that will be number. So C plus 11 minus 1, so this will be equal to C plus 10. So now it is as good as the printf. So if you do C is here and C plus 10, so C will be here. So C plus 10, so if C is here, so C plus 10 will be here. So what it will print? After this, the string is this. So a string length don't count the null character. If size of operator is there, it will count the null character. So it will, a string length, we have only a string left. This C plus T will only point to this 17, 1 and 7, like this. So C is now here. So if you print up to this, it will give you a printf, a string length, a string strlen. The string is only 1, 7 there. So length of this string is 2. So answer here is 2. So this will print 2 because C plus 10 will move to this place. So this and null is not in a string length function. It is a predefined function in C in conio.h header file, and it does not count the null character. So we have 1 and 2. So the fill in the blanks, the right answer here is 2. So this is the end of the question. So now let's solve this recurrence lesson. This question is about recurrence lesson. Right. So here we cannot apply master theorem as it is, but we can apply the iteration method or extension method. So let's start. So master theorem, for master theorem applying, we should have a recurrence lesson in a proper form, like Tn equal to Atn by b plus 1. So whenever we have root, we cannot apply master theorem. Right. So it is like plus 1, and this is base cases when n is less than equal to 2, the Tn value is 2. So we will not use base case. So if now Tn is calling T root n, so if you in place of n, if you pass root n in this function, so here in equation 1 what we are doing, in this we are replacing n by root n. So it will be 2 T2 root of root n, right, plus 1. So this whole thing is nothing but replacement of this. So from 2, just what we can do, so use the value of this will be replaced by equation 2. So 2 just, so here we have 2 root of root n, right, and this plus 1 and then plus 1, like this. So say, although it is complex, but it is very easy, we can write root of root n. So this is nothing but n to the power 1 by 4 plus this 2 plus this 1. So similarly, if you go to another level, it will give you T n to the power 1 by 2 to the power 2. So it will be, this is 2 power 2. So it will be 2 power 3, and we have 2 power 3 plus 2 power 2 plus 2 power 0, this one. Right. So now in this way, if you go, let's kth step, so it will be T. So if you go to, if the height of this tree is k, so n 1 to the power 2k plus this will be 2 power k minus 1 if it is 3. So here we have total 3 terms, right? So 2 power k minus 2 till 2 power 0. So it is how many terms? It is k terms. Right. Now we have to come to the base case. When base case will be seen, so if the inner thing is 2, if you see if n is 2, the Tn value will be 2. So to reach base case, what will we have to do? So if n 1 by 2 power k is 2, this to reach base case. So how, basically we need to find k in terms of n, because this is the k only that is going to give you the cost of this recursion, cost of this recurrence lesson. So how to solve? So we'll do the power of 1 by 2 to the power q. This is 1 n to the power 1 by 2 power k. So if you raise 2 power k both sides, so this will cancel out. So it will be n equal to 2 to the power k. Now 2 power k will be equal to n. 2 to the power k equal to log n, right? 2 power k equal to log n, right? Because if you put log n both the side, so this again if you want k, so log of log n, right? So what is the cost? So it is 2 power k, and this is 1, and this is, if you put together, this will be also 2 power k, because 0 to power 0, so if you put together it will be 2 power k. So 2 power k in 2 power k is the cost, and 2 power k is what? Log n. So the time complexity of this asymptotic recurrence lesson is log n, like this. So you can solve like this. So this is the answer, and this is a simple method. Just you have to use a basic mathematics. we have iterate and reach k and extrapolate this 2, 3, then we have extrapolated it till k, and we have to find the value of this k. So k is expressed in terms of n. If we reach base case, so this in order to reach base case, if base case is given, so when n is less than equal to 2, this will be the whole thing will be 2. So this is replaced by 2, and we have to find out 2 power k this side, 2 power k this side. So we got 2 power k is log n, and this is 2 power k into 1, because this is basically 2, right? So this is 3 to the power 2, 3 into 2 power k, and 2 power k is log n, and this is constant. So answer here is log n, which is B is the right answer. B is the correct answer. So this is the end of the solution. So in this particular question, we are asked to find the complexity of function fun in terms of theta notation. And if you see all the options, we have the same notation. So that is not a big problem. Let's start. There are 2 loops, and we have to find the loop inside loop is there. So let's find the total time complexity. The function is like this. So fun int n, and here we have int ij for I equal to 1, I is less than equal to n, I plus plus 4, j equal to 1, j is less than n, and j equal to j plus I. And then there's a parenthesis inside this, printf ampersand d ij. This is end of the code. Now the complexity of the function and fun in terms of theta is, right. So see, when this dependency is j is less than n and j equal to j plus I, So if you see, what would be the time complexity of this function? The time complexity of this function is the time complexity of this statement when it executes true, or the time complexity of the function when the inner loop is true, because inner loop is the most time executing. Outer loop will only run for n time, but inner loop for every n time, inner loop will execute like this. So will execute like this. So if you see, basically time complexity of this program is nothing but time complexity of this function is nothing but time complexity of inner loop, or you can say, or time complexity of innermost statement, time complexity of the printf. How many times printf get printed? Means time complexity of printf statement means number of times printf will, this one means how many times this statement is going to occur. So if you see outer loop, if I equal to 1, so inner loop will run for how many times? So this will be the inner loop will run for, j will run for n time, right. If I equal to 2, the j will run for, so it is 2. So here what we is doing? So we are, every time we are writing j equal to j plus 2. So to reach n, j will run for how many times? N by 2 times. The inner loop. Are you getting? See, initially I is 1, so it will be incrementation is done by 1. So this whole loop, inner loop will run for this. For I equal to 1, inner loop will run for n times. When I is 2, so j equal to j plus 2. So whenever you have j equal to j plus 2 to reach, and you started j equal to 1, so to reach n you require n by 2 times, n by 2 steps, because every time you are making increment of 2, and you have to reach n, you started from 1 and you are always making a increment of 2, so you will reach in n by 2 steps. So when I equal to 3, j will be what? You will reach in n by 3 times, right. So similarly, when I is n, j will run n by n times, right? So total sum of the j loop, when inner loop, so if you sum up it, so n plus n by 2 plus n by 3 plus n by n, right? So if you solve, this is n into 1 plus 1 by 2 plus 1 by n, and this is equivalent to log n. This is equivalent to log n. So n into log n is the time complexity. So answer here is C. I hope this is the main thing. Time complexity of this function is nothing but, time complexity of any program is nothing but the time complexity of the statement which runs for the maximum time. So this loop is inside this and this is inside this. So either the time complexity of this or frequency of this statement or frequency of this statement is going to the time complexity of overall. So now if you see the inner loop, j equal to j plus I. So I was 1, so j, every time we are making increment of 1. So inner loop will run for n time. When I will become 1, I is 2 for outer loop. So every time what we are making, j equal to j2. So to reach n we require n by 2 steps because j is 1. Now next time we have I is becomes 3, so we are making j equal to j plus 3 and we have to reach n and we always take a step of 3. So to reach n we require n by 3 step. So like this, so these many times I will, first time I will, inner loop will run for, outer loop will run for 1 time, then this time j inner loop will run for this. If outer loop run for 2, this will run for this. So if you sum it up, it is going to be n log n. So answer is C, and this is the end of the question. Now we are given a binary search tree and the pre-order traversal is given. We have to find the post-order traversal of the tree. So it's a BST, right? And so BST, we know the inner traversal in BST, inner traversal displays the value in ascending order. So in case of BST, the inner traversal is implicit. Just you have to arrange the value in ascending order. That will give you the BST. So inner traversal of traversal displays the value in ascending order. And we need, in order to generate the tree uniquely, we need in order, one order is in order and second will be either pre or post. So one in order traversal is necessary to generate a tree, binary tree uniquely. And in case of BST, in order traversal is very implicit. So first let me tell, it's a pre-order. So pre-order is given in the question. So pre-order is 12, 8, 6, 2, 7, 9, 10, 16, 15, 19, 17, 20. And so what would be the in order? So if you took all the value and you arrange them in ascending order. So the first is 2, 6, 7, 8, 9, 10, 12, 15, 16, 17, 19 and 20. This is just I am using this idea because whatever the key value are here, we are using them and I am sorting them in ascending order. Now how to construct a tree from in plus pre? So to construct a BST, to construct a tree, just I hope you must be knowing, to construct a binary tree BST from or any binary tree from in plus post, in plus pre-order. So there is 2 line, right? In plus pre-order, because if we have in order, there in order traversal gives a perfect trend. The value left 2 of a node will be in the left subtree. The value which are right 2 of a node will be somewhere in the right subtree. That we use. That is, in order traversal gives a perfect trend. So to construct a binary tree from in plus pre-order traversal, in order plus pre-order traversal is select key value 1 by 1 from LHS of pre-order, right? And then for each value, for its position, refer in order traversal. This 2 line you have to remember. So select key value, select a key value 1 by 1 from LHS of pre-order, and for its position refer in order traversal. So for n key value we have to do this activity n times. So first is 12. So, and also we know the first node in pre-order is root, that is, and last node in the post order is root. So if you see in all, the post order must contain the last node as a root. So 12 is the root, so it should be in the last. So if you see B, C, D has the 12 as the last value, but we have still 3 options. We don't have 1 option. So first 12. Now 12 is here, right, mark. Now next is 8. So what is position of 8 with respect to 12? So position of 12 with respect to 12, position of 8 is in the left side, so it will be in the left subtree. Next, what is position of 6? So we have chosen 8 and 12, so position of 6 with respect to 8 and 12 is left. Then 2, so position of 2 is again with respect to left of 6. 6 is the last node. This is the tree. Now 7, so 7, position of 7. So if you see with respect to 2, 6, it will be right. With respect to 8, it will be left. So with respect to 8, it will be in the left. So 7 will be here, this. Next 9. So 9, position of 9 with respect to 12 and 8, it is right. So it will be 9. Next 10 with respect to, so it will be 10 will be here because we have 9. So with respect to 12, it is left. With respect to 8, 9, it is right. Next is 10 we have already done. So 10 is here. Then 16. So 16, position of 16 with respect to 12 is right. So it will be right. Next 15, position of 15. So with respect to 16 it is left. With respect to 12 it is right. So it will be 15. Right. Next is 19. So 19, position of 19 will be in right side. Next 17. So position of 17 will be left of 19, right of 16. So left of 19, so like this. And then 20 will be here. And what is a post-order traversal? So post-order traversal is left node, right node, left subtree, right subtree and node. So first will be, we will go. So 2, then 7, then 6, then 10, 9, then we have 8. And then 15, right? Then 17, then 20, then 90, then 16, then 12. So the answer here is B is the right answer. So if you see 2, 7, 6, 10, 9, 8, 15, 70, 20, 19, 16, 12. So B is the right answer. So this is the end of the question. So in this question we are given a C program and the variable x, y, q all are unsigned integer, and which of the following conditions on the variable x, y, q and r before the execution of the fragment will ensure that loop terminates in a safe state satisfying the condition x equal to, so x is equal to, we have to find y into q plus r. So basically we are dividing x by y. This is the target. And if you divide x by y, so using repetitive other than subtraction, it is division is done by using subtraction. So initially what will happen, x, y. So what are the conditions to be hold true? So see the q, because see if you see the loop, the q every time we are making q equal to q plus 1. So initially in the loop when r goes to y, so r should be equal to x because this is y. This is y, so this is, we are dividing by 2. So if this will continue till r is greater than y, so r must be initialized with x, right? R must be initialized with x, and this is y because y, you can only divide a number if y is greater than 0. So this is also true, y needs to be greater than 0. And this q, in every time we are making q plus 1, q equal to q plus 1 if you goes to loop. So the q should be initially assigned with 0. So q should be equal to 0. So this condition should be there. So this condition is given in C only. So right answer of this question is C. So this is the end of the question. So now this is question about Huffman coding, and characters are given there are 5 characters P, Q, R, S, T, and their probability are also provided. If a message of 100 characters over X is encoded using Huffman coding, then the expected length of encoding message in bits is. So first of all, what we have to do, we have to find the Huffman code. The first thing, find the Huffman code for each character. And the moment when you get the Huffman code for each character, then find the average length of the find the average length of the coding. Find the average length of the coding. Find the average length of the coding. Now when you have the average length of the coding, so that length into 10, your answer will be, so this average, so average length, right, and answer of your questions will be average, this average length into 100, right. This is the required thing we have to do. But the main thing, how to find the Huffman coding. So if you see the Huffman coding, for finding Huffman coding, we have to arrange the codes in ascending order. I'm not going to tell you the step, but the step is we have to arrange the codes, characters in ascending order of probability, and we'll took 2 characters whose probability is list, and we'll construct a binary tree, partial binary tree, and whose parent will have the value of both the probability, sum of the probability of both the tree. So if you arrange it, arrange characters in ascending order of probability, right. So first character will be what? It will be 0.08. So so this is average length. So find the average length. So this is 0.08 of whom? 0.08 is of T. Then we have 0.17 of R. Then we have 0.19 of S. Then we have 0.22 of P and 0.34 of Q. So what? Arrange. Now the moment when we arrange, we will construct a partial binary tree. So partial binary tree, the sum of the character probability of the parent node will be sum of both. So this will be 0.25. And again repeat this step. So the moment when you do this 0.29 will be less than this. So I am shifting 0.19 this side after S. So again after this, this is not true, because after we have this scenario. So again if you order it, the scenario will be like this. This 19 and this 19 and now it is 0.25 and this has 2 less value. So the next thing will be what? So this will be 0.48, 0.41, but after adding it, because this is now after this 0.25 I am jumping a step, 0.25 here it is 0.9, 0.22, so this will be shifted here, and we'll choose 2 node. We'll choose 2 node, 2 character with a smaller probability. So this will be 0.9 and 0.22, so sum of this will be 41. Now if you arrange them, it will be 0.34 somewhere, so 0.34, and 0.34 is of whom? Q. So if you add this 0.24, 0.34, so sum of this will be added, so it will be 0.59. Now we have a 59 and we have 41.41. So again we have to bring this here. So 0.41 and the sum of these 2 will be 1. And this will be here. So here we have S, here we have 0.19 and 0.22. So this is the tree structure we have got. So if you start coding, the length of coding of S will be 2. So length of coding will be 2. So average length will be, find the average length. So average length of each coding is length into the probability. So the length of this is, because 0, 0, or if left side we give 0 and right side we give 1. So the code of S will be 0, 0. Right. The code of P will be 0, 1. the code of T will be, so 0 1 1 0 0. The code of R will be 1 0 1. The code of Q will be 1 1. But the matter of the fact is the code of S, P and Q is 2. So 2, the length of this is 2. So 2 into, so probability is 0.19 plus 0.22 plus 0.33. This is the average length. What is average length? So it is nothing but length of the code into probability. So length of P, S and Q is 2 and their probability we are adding plus 3 into 0.08 plus 0.17. So if you sum it up, you will get 2.25. 2.25. And answer is average length. This is average length. This is the average length. Average length, again I am saying average length of the coding scheme is that the length of each code into its probability. So length of S, P and Q is 2 and the probability is this. We have to add. The length of these two is 3 and probability is 0.08. So like that. So 2.25 and we have 100 characters. So 2.25 into 100. So this will be 225. So correct answer of this question is 225. This is the end of the question. So now let's solve this particular question, and here we are given some variables. So the coding is like this. So we are given int main, int m equal to 10, right, int n n1, n equal to plus m. So see, this is a pre-increment, a first increment then assignment. So the value of n will be, let me write first, n1 equal to m plus plus, then we have n minus minus, we have minus minus n1, right, and then we have n equal to n minus n1, and printf %d n. This is the question. So see here, what is the value of m? So here after doing this, the m value will be 11 because plus pre-increment, and n value will be also 11, right? Then after this step, n1 will be equal to what? N1, this is a first assignment then increment, first assignment then increment. So n1 equal to m plus plus, what is m? 11, but assignment will be only 11, and then the increment will be done later. So m value will be what? 12, because 11 plus plus. Now n minus minus. So n minus minus will be 10. Minus minus n1. The minus minus n1. So minus minus n1. So n1 value will be what? 11 minus 1, because pre-increment. So 10. So now n equal to n minus n1. So 10 minus 10 will be 0. So answer of this question is 0. So this is very easy question, just we have to follow the steps. The difference between it is pre-increment. So first we increment and then assign. Here it's a post increment. So first assign and then do the increment. So with this we have got the answer as 0. This is the end of the question.